Equations. Anyone know what a literal equation is?
A legit equation.
It's a legit equation. Okay. Not quite. Here's what a literal equation is. There we go. An equation that has two or more variables is called a literal equation. If you didn't know that, now you do. To rewrite a literal equation, solve for one variable in terms of the other variable or variables. So it's going to give us an equation with two or more variables. It's going to ask us to solve for one of the variables. So my goal is to get that variable isolated by itself on one side of the equation. We're still using our inverse operations. It's just going to look a little different because we have more than one variable there. Does that make sense? Still the same processes though. Are there any questions about what a literal equation is or how we solve them? See some people writing, so I'm going to wait a second to move on. Am I good to move on? Solve the literal equation. 3y plus 4x equals 9 for y. So like I said, it gives me an equation. It wants me to solve it for y in this case. So my goal is to isolate y by itself on one side of the equation. Now remember, before I can get the variable by itself, I need to get the term containing the variable by itself. So which term is containing the variable we're trying to solve for? The what? You got a term here. Term here. Which one's containing the variable I'm trying to solve for? 3y, right?
3y.
3y is my term that contains the variable, correct?
Yes.
So before I get y by itself, I need to get 3y by itself. So how would I get 3y by itself? What?
Would you subtract 3?
Now subtract 3.
Minus 4.
Subtract 4x from both sides. Both sides of the equal sign. So on the left-hand side, I'm left with 3y. On the right-hand side, I have 9 minus 4x. Can I combine those two things?
No.
No, they're not like terms, are they? They both don't have an x. So I just write it as 9 minus 4x. If I can't combine them, I just have to write it out like that. Any questions on that? So we said the term containing the variable is 3y. Is 3y now by itself?
Yes.
Yeah. Now that the term containing the variable is by itself, I can now focus on getting my variable by itself. So now how would I get y by itself? Divide by 3. Now when I add or subtract something to both sides, I just combine it with whatever it'll combine with. When I'm multiplying or dividing by a number on both sides, I have to multiply or divide every term by that number. Okay? Anytime I multiply or divide on both sides, all the terms have to get multiplied or divided by that number. So I'm doing 9 divided by 3, which gives me 3. I'm also doing negative 4x divided by 3. Will that give me a whole number dividing 4 and 3?
No.
No. Can I simplify that fraction at all?
No.
Nope. So I'm going to leave it as minus 4 thirds x. Is y now by itself?
Yes.
Yeah, there's my answer. So our answer is not just going to be a number. Our answer is going to contain all the variables. Okay? We're just rearranging our equation to get a certain variable by itself. So like I said, we're used to seeing a variable equals some number. Our answer is going to contain the other variable though as well. So here we get y equals 3 minus 4 thirds x. Any questions about that? Now, if you wanted to, this is what I'm going to do throughout the rest of the notes. When I subtracted 4x to both sides, I like to write the variable first. So I would write 3y equals negative 4x plus 9. You just have to make sure the correct sign stays with the correct term. Everyone got that? So I would have gotten y equals negative 4/3 x plus 3. That's just my personal preference, is to have the variable come first. So that's what I'm going to do throughout the notes. Questions on example 1? How do you feel about this so far with one example? Okay, at least? Okay, can I erase and move on? Actually, I just need to move on. Okay, 3 more examples, very similar to my previous example. Solve the literal equation for which variable? Solving for y, trying to get y by itself. So number 1, 3y minus x equals 9. Raise your hand if you can give me my first step.
Plus X.
Very good. I'm going to add x to both sides. Can I combine 9 and x?
No.
Bless you. No, I can't. So I'm going to write it as x plus 9. Once again, if you put 9 plus x, that would not be wrong. You can do that all day long if you want to. Raise your hand if you can give me my next step.
Divide by 3.
Very good. Divide both sides by 3. On the right, what am I dividing by 3? 9
Both.
and x. Every term gets divided by that number. So that's a 1x over 3. If I do 1 divided by 3, will that give me a whole number?
No.
No. Will it simplify at all? No, so I'm leaving it as 1/3 x. Plus, what's 9 divided by 3?
3.
3. Is y now by itself? Yep, there's my answer. Questions on number 1? We okay still? Okay, number 2. Am I moving too fast for anybody? I can slow down if I need to. Number 2. 2x minus 2y equals 5. Raise your hand if you can give me my first step. Not add 2x. Subtract it, right? It's a positive 2x. So I'd have to subtract it from both sides in order for it to cancel, right? Because 2x minus 2x is going to give me 0, right? If I added 2x, I would have gotten 4x, which that would not have eliminated it from the left. So we got to make sure we do the operation that eliminates it. So on the left, I get negative 2y. That minus 2y makes my 2y negative. Can I combine 5 and negative 2x?
No.
No. So I write it as negative 2x plus 5. Or 5 minus 2x, whichever you prefer. Questions on that step so far? Raise your hand if you can give me my next step. Very good. Divide by negative 2 on both sides. What gets divided by negative 2? 5 and negative 2x. Every single term gets divided by negative 2. Negative 2 divided by negative 2.
1.
Positive 1. X or just x.
X. Just X.
5 divided by negative 2. Will that give me a whole number?
0.
No. Can I simplify that fraction at all?
No.
No. So it's just minus 5 halves. Is y now by itself? Yes, it is. There's my answer. Question?
Why would it be subtract? Yeah. 5 over 2.
Oh, because it's a positive 5 being divided by a negative 2, right? Positive divided by a negative gives me a negative. So I just made my whole fraction negative.
Okay.
Any other questions on number 2? Am I good to move on to number 3? Raise your hand if you can give me my first step. 20 equals 8x plus 4y. Yeah, very good. Subtract 8x from both sides. Can I combine 20 and negative 8x?
No.
No, so I'm going to get negative 8x plus 20 equals 4y. Questions on my first step? Raise your hand if you give me my next step. Divide by 4. What else on the left gets divided by 4?
Negative 8 and 20.
Negative 8 and 20, both terms, right? All the terms get divided by that number. Negative 8x divided by 4.
Negative 2.
Negative 2x. 20 divided by 4.
5.
5. And then I have y. Is y now by itself?
Yes.
Yep, so there's my answer. Any questions on number 3? Yeah. Yeah. So the second step? Yeah. So y is being multiplied by 4. So I've got to divide by 4 to cancel it out over here. I've got to divide both terms by 4 over here. Okay, anytime I divide both sides of an equation by a number, every term gets to be divided by that term. So negative 8x divided by 4 gives me negative 2x. 20 divided by 4 gives me 5. And then I have y by itself. How are we feeling about this now after a few examples? Feeling pretty good. Some of us still a little shaky, but better than before. Better than after our first example, hopefully. Are there any questions up to this point? Okay, can I move on? Okay, another example. Solve the literal equation. Y equals 3x plus 5xz. Solving for x this time, not y. Solving for x, trying to get x by itself. Any ideas on what I need to do first here?
Subtract 5xz.
Okay, we can try that. Let's try it out. Can I combine y and negative 5xz? No. So I'm going to write y minus 5xz. I get 3x on the right.
Wait. Oh, that y. Oh. Yeah, I see that y.
Pay attention to the y. What would I do next here? Probably divide by 3, right?
Yeah.
So I'd get y over 3 minus 5xz over 3 equals x. Well, I got one x by itself, but I have another x within my equation. We don't want that. We just want all the x's on the same side, solve for the one x. So this is probably not going to work out for us in this case. So I'm going to erase. We don't need to do that. It's a good thought. It's a good thought. Any other ideas here?
Subtract 3.
Subtract 3x. We can try that. Y minus 3x equals 5xz. So then you'd probably divide by 5z, right? So the 5's will cancel and the z's will cancel. So I get y over 5z minus 3x over 5z equals x. Well, kind of the same thing there. I got one of the x's by themselves, but I still have an x within my equation, right? So that's probably not going to work out.
Can you not do it?
No, we can do it. We can do it. Do we have like terms here? No, if that 3x had a z with it, then they would be like terms, but it doesn't. Y'all want me to just tell you? Okay. Have you heard of a GCF before? Okay. Greatest common factor. We heard those words before at least. We've never heard of a greatest common factor. Okay, some of us have, some of us haven't. That's how we're going to solve this equation. Because right now, everything we've tried to do did not get x by itself, did it? I still had an x remaining in the equation. Okay? So what? That's because I've got two separate x's that I cannot combine. So what I need to do is factor out a GCF from these two terms. It's the biggest set of numbers and variables that these two have in common. Okay? So, looking at the 3 and the 5, is there a number besides 1 that goes into 3 and 5 at the same time? That goes into them. Not that they go into. Besides 1. No. So I can't factor anything out from those two numbers. Do they have an x in common? Yes. So I'm going to do what we call factoring out an x. If it'll pop up on my screen. There we go. I'm going to factor out an x. Do they have any z's in common? No. Okay, what we're doing here is we're undoing the distributive property. We all know distributive property, right? So we're going backwards from the distributive property. We'll call it undistributing. We're undistributing this x. So I've got to keep distributive property in mind here. If I did distributive property here, x times what would give me 3x? 3, right? And then x times what would give me 5xz? 5z, right? And that'd be it. If it'll pop up. There. That would be it. Does everyone see how this first original equation is equivalent to this equation I just created? If I were to distribute this x back through, I'd get back to my original, correct? Does anyone see how that helps us? How?
So what happens if a number can go in and then plus minus 1?
You would have to factor out that number as well as the x. Okay? How does this help me out here now?
You can
Yeah.
times it.
Can you just do it how we did it in the other ones now?
How would I do that? Well, in my original equation, I had two x's separate that I cannot combine, right? So I couldn't get it by itself. Do I have two separate x's now? No, I've got x in one spot, don't I? That's probably going to help me quite a bit because I'm trying to solve for x, right? Any ideas how I'd get x by itself right here? It's okay if you're wrong. Just someone give me an idea.
X times 3 and this times 5.
So you're saying distribute it back through? If I did that, I'd get back to my original problem, right? And I didn't want that. That's why I did what I did, right? Okay. I have a multiplication problem here, right?
Never mind.
Got a multiplication problem. It's x times 3 plus 5z. What am I trying to get by itself? X. Right? What's with x on that side of the equation? What? What's with the x?
3 plus 5z.
3 plus 5z. And it's being multiplied, right? What's the inverse of multiplication? Division. So what do you think I could divide by to get x by itself?
3 plus 5z.
3 plus 5z. If I divide by 3 plus 5z, it's in the numerator and it's in the denominator, so they will cancel out with each other. There. Just like that. Whatever I do to one side, got to do to the other. So I get y over 3 plus 5z equals, and now I have x by itself. That's what I want. There's my answer. Does everyone see that? So originally, I had some x's that I could not combine, so I was unable to solve for x. So I had to factor that x out, that GCF, in order to get x in one spot, and then I could then solve for x. Any questions there? Any confusion? Okay, here we go. y equals 5x minus 4x. What do I need to do here first? Y equals 5x minus 4x. Yep. Yeah, here we can just combine like terms, right? What are my like terms? 5x and 4x. What's 5x minus 4x? 1x or just x? What variable am I solving for? X. Is x now by itself?
Yes.
Yes, it is. There's my answer. So that one's easy. If you can combine like terms, go ahead and combine like terms. You could have approached this by factoring out a GCF. Let me show you how. Their GCF on the right is x, right? They both have an x in common. X times what would give me 5x? What? X times what would give me 5x? 5. X times what would give me negative 4x? Negative 4. I don't know why it's going so slow today, but. So then what's 5 minus 4? 1. And then you can look at this two different ways. X times 1 would give me x, so y would equal x, which is what we got. Or you could divide both sides by 1. Y divided by 1 is y, so I'd still get y equals x. So you could still approach it using the GCF in this case. But I like you to use like terms, so if you can combine like terms, combine them, and then solve. Okay? Any questions on number 4 here? Okay, number 5. 2x plus kx equals m. 2x plus kx equals m. Raise your hand if you can help me out on the first step. 2x plus kx equals m. Got to use my GCF here, right? Can I combine any like terms? No. There's no way I'd be able to get x by itself because I have an x in two different spots that I can't combine. So what is my GCF? What do those two terms have in common? Here and here. X, right? So I can factor out an x. X times what would give me 2x? 2. And then x times what would give me kx? X times what would give me kx?
1.
K.
Okay.
Right? Everyone okay with that first step? How would I get x by itself now? By 2 plus k. It'll cancel out in the numerator and the denominator. Whatever I do to the left, I have to do to the right. Is x now by itself?
Yes.
Yep, there's my answer. Questions on number 5? How are we feeling about this part? Okay. Last one, number 6. 3 plus 5x minus kx equals y. 3 plus 5x minus kx equals y. So what do I need to do here? GCF? Well, when I do a GCF, I have to pull out a GCF for every term on that side of the equation. So do they all have an x in common? No. 2 of them have an x in common. So what do you think I need to do with that 3? Yeah, subtract 3 from both sides. So I get 5x minus kx equals, can I combine y and 3? No, so I leave it as y minus 3. Now what do I need to do? Now I can do my GCF on the left. What's my GCF? X. X times what would give me 5x? 5. X times what would give me negative kx? Negative k. Any confusion up to this point? Now what do I need to do? Divide by 5 minus k. Is x now by itself?
Yes.
Yeah, it is. Any questions on these types of problems? Now, make sure on your assignment you are reading the directions and seeing which variable it wants you to solve for. Sometimes it'll be y, sometimes it'll be x. If it asks for x and you solve for y, you'll be wrong. If it asks for y and you solve for x, you'll be wrong. So make sure you pay attention to what you're solving for. Here's our assignment. Page 50, numbers 4 through 26 evens. This will be due Thursday. That is the 8th on Canvas. On Canvas, it'll be 1.7. Homework number 1. Make sure you get the correct heading on your paper. Name, date, period, assignment, upper right-hand corner. This is your assignment that you put on that last line in that heading. Get this written down so I can take it off the board. Do we have any questions about my notes before I end my recording?